Hey guys, welcome back. We are now moving on in our transformations unit to dilations. Up until this point, we have only worked with our rigid transformations. So a translation, a slide, a reflection, a flip, and a rotation, a turn. Now we are moving on to dilations, and dilations are not rigid because they affect the images or the shape's size. If we think about what the word dilate means, the best example that I can think of is your eyes, because the pupils, so that black part in your eye, it dilates according to the amount of light that is around you. So that way it can dilate and according to make sure you can see things properly. And if you've ever been to the eye doctor, they'll put some drops in your eyes to dilate them to help with the exam. When you see a dilation, that means our image, in this specific case, we have a triangle. It is either going to be increasing in size or decreasing in size. It's either going to grow or shrink. And the way we determine not only whether it's growing or shrinking, but by how much is our scale factor. If we read the directions here, it says write the coordinates of the vertices after a dilation with a scale factor of 4, and it is centered at the origin. Those are my favorite kinds because they're the easiest. So my scale factor of 4, that identifies that it is going to be growing by 4 units. And because it's centered around the origin, so at 0.00, we don't have any extra steps or anything because it's growing around the center of our graph. Now, to determine its new points, to determine its size, you are going to multiply the original ordered pairs by your scale factor. So we are going to multiply point R, S, and T, all of those by our scale factor of 4. When we multiply them, we do need to remember to multiply both our x value and the y value, because the entire point is being, in this case, blown up by a scale factor of 4. Let's look at point R. Our x value is 0. So what's 0 times 4? Still going to be 0. All right, now we also need to multiply our y value by 4, which is -1. What's -1 times 4? -4. And let's go ahead and graph this point so that way we can see visually the enlarged image. So 0, -1, 2, 3. So right here. Oh, oops. Oh no, we're good. It becomes our R prime. All right, now let's dilate point S, which is currently located at 0, 1. Same process, it's being dilated by the same scale factor. So we're going to multiply both the x value and the y value by 4. 0 times 4 is 0. 1 times 4 is 4. S prime is now located at 0, 4. Here's our new location for S prime. And last but not least, T. So point T is also multiplied by a scale factor of 4. So 2 times 4 is 8. -1 times 4, -4. So T prime is at 8, -4. Let's grab some lines here because I know that if I try to draw the lines, it's not going to be very pretty. We now have our dilated triangle. See how it's larger? It was dilated by a scale factor of 4, which means it's going to increase in size. All right, let's type these answers in so we can do a new problem. There we go, sweet. Okay, Ooh, now we're going to dilate by a scale factor of how much? So write the coordinates of the vertices after the dilation with a scale factor of 1/5. And it is also centered around the origin. Okay, so that's good. Now, if we think about this for a minute, in the last example, our scale factor was a whole number, and it increased in size. Now our scale factor is a fraction. Do you think that means it's going to be dilating and getting bigger, or dilating and getting smaller? It's going to be shrinking in size. It's going to be getting smaller. And the reason that that's important is because it allows you to kind of double check your work. Because if you finish and you get your answer and you realize that your triangle is not smaller, it means, ooh, something's wrong. But guess what? The process is the same. We're going to multiply all of these numbers by a 1/5, which is the same as dividing by 5. So no matter which way you look at it, whatever works better for your brain, you're either multiplying everything by 1/5, but that is also the same thing as dividing everything by 5. No matter how you look at it, you'll get the right answer. Okay, let's go ahead and work our way through. So point C is located at 0, -5. We're going to multiply both numbers by 1/5. 0 times 1/5 is 0. -5 times 1/5 is -1. Let's graph that point. There we have our new C prime. All right, point D is at 5, -5. Our scale factor is 1/5. We need to multiply both values, both the x and the y, either by 1/5, or that's the same thing as dividing by 5. 5 times 1/5 is 1. -5 times 1/5 is -1. Got some pretty friendly numbers here, which is nice that IXL did that for us. So D prime is at 1, -1. Oh my, that's so close together. Look at that. It's crazy. And last but not least, E, which is at 5/10. 5 times 1/5 is 1. 10 times 1/5 is 2. So E prime is at 1, 2. And we had said at the very beginning, because our scale factor was less than 1, we should have a smaller triangle. And do we? Yes, we do, which is a great way to help double check. All right, after we confirm that this is correct, we'll do one more example. Let's jump up a level here. Okay, still the origin. I want to see if there's any that are not around the origin. Okay, it doesn't look like it. But what I will do is, since it doesn't look like there's any examples of anything being around the origin, I will include in the assignment on OMHS, guys, a separate video that another teacher's made, and it's awesome, of how to dilate a figure that's not on the origin, just in case there's one IXL that sneaks in that's like that, okay? All right, we'll just go ahead and do one more then for good measure since we're here. All right, draw the coordinates of the vertices after a dilation with a scale factor of 3, and it is still centered around the origin. So scale factor of 3, because it's around the origin, all we have to do is multiply all of our values by 3. Let's start with F. -3 times 3, -9. 2 times 3, 6. All right, point G, 3, 2. Multiply that by our scale factor of 3. 3 times 3 is 9. 2 times 3 is 6. Very similar answer. No, I forgot to graph that other one. So let's graph this real quick. 1, 2, 3, 4, 6. Here's our G prime. Let's go back and graph our F prime. And then H is at -3, 3. -3 times 3 is -9. -3 times 3 is -9. So that would be right here. And because, forgot to ask this last time, but because our scale factor is a whole number, that means our dilation is an enlargement. Our triangle got a lot bigger. All right. So as I said, guys, in case you do get an IXL question where it is not dilated around the origin, just go right below on the assignment and you'll see that there's a second video there that another teacher has made with a great example on how to dilate an image when it's dilated around a different point. Okay, but as always, if you have questions, just send me an email, or of course come to my help sessions, because that's even better. We can communicate back and forth. Bye, guys.